Hi. In this fourth presentation of the Groundwork playlist, we will formally present the main types of concurrent and sequential statements. So at the end, you should be able to describe the main types of statements belonging to these two types and explain how they can be used. As you might expect, the presentation is divided into the two parts shown here. Let's then start by the main concurrent statements. There are four main concurrent statements that we will use extensively during this course: concurrent signal assignments, conditional and selected signal assignments, and the process statement that encapsulates the execution of sequential statements. Chapter 11 of the IEEE 2008 standard provides further details and describes additional concurrent statements, but for now it is sufficient to know those that will be presented here. Concurrent signal assignments are the type of statements that we have seen before in the data flow description of the 2 to 4 decoder. They will become sequential signal assignments when encapsulated inside a process, but when used as shown here, they will be executed concurrently and therefore are concurrent signal assignments. You may recall the when-else statements that were used with the first behavioral model presented for the 2 to 4 decoder. The when-else statement is actually one of the main concurrent statements and known as the conditional signal assignment type. The with-select statement used in the second behavioral model presented for the 2 to 4 decoder is the third main concurrent statement and known as the selected signal assignment type. It might be useful to know these names by heart, but you shouldn't worry if you don't. The important thing is to know that they exist and to know where to look for information when you need to use them. The last main concurrent statement is also very frequently used. It is the process statement, which we have referred to more than once before. The statements encapsulated inside the process statement execute sequentially, as we will see in a moment, but the process statement itself executes in parallel with the other concurrent statements. This slide shows how to describe the 2 to 4 decoder function using a process statement. The if statement used inside the process is a sequential statement, as you might expect, and so it will be presented later, but for now I would like to call your attention to the fact that the process declaration comprises a list of signals enclosed by round brackets. This list is called the sensitivity list. The process will be activated or triggered whenever at least one of the signals in its sensitivity list changes value. Choosing the signals to include in this list is critical to ensure proper operation of the circuit, and failing to do so is a frequent source of headaches and design problems. We will see later that when a process is defined without a sensitivity list, it will trigger immediately from the start, and in that case we will need to include a wait statement inside to suspend its execution. Let's now consider the main types of sequential statements. There are four main types of sequential statements that you will come across frequently during this course: sequential signal assignments, the if statement, the case statement, and the wait statement. This class of statements is presented in Chapter 10 of the IEEE 2008 standard, but it will be sufficient to follow this presentation. The sequential signal assignments shown here have been presented before, and as it has been said on that occasion, it is meaningless to use them in this case. The reason is that they will execute sequentially, but they will take effect at the end when the process suspends, and as such, Virvado treats them in the same way as if they were concurrent signal assignments. However, we may use this example to illustrate what is a sequential signal assignment. The if statement is the second main sequential statement, and this slide repeats the same description that was presented a while ago to illustrate the process statement. The if statement can only be used inside the process, and sequential execution in this case means that the Boolean conditions indicated will be evaluated in sequence until one of them is found true, and in which case the corresponding branch is executed and the process is suspended. An earlier presentation called your attention to the fact that concurrent and sequential statements are not respectively related to combinational and sequential circuits. I noted then that both types of statements can be used to design both types of circuits, and this example shows that an if sequential statement being used to design a combinational circuit. Notice also that this is another form of behavioral description, since we only care about what is to be done and not how it will be done. The third main sequential statement that we will consider is the case statement, which, like the if statement, can only be used inside the process. This slide shows yet another form of behavioral description for the 2 to 4 decoder, and it reinforces an idea that you should have developed by now. The same function can be described in many different forms in VHDL, and experience, and sometimes common sense, will tell you what is the best choice for any given situation. The syntax of the case statement is shown here, and in this case the sensitivity list of the process comprises only one signal. However, if you look closer, you will see that cell is a 3-bit signal that results from concatenating the 3 decoder inputs. So once again, the process will be activated whenever any of these inputs changes value. The fourth and last sequential statement that we will consider is wait, which is synthesizable in some of its forms, but which will be used in this course with the sole purpose of suspending the execution of a process statement used in a simulation source file. And this concludes the presentation of the main concurrent and sequential statements. Thanks for your attention.